Alright guys, this is the fifth video. You'll see that at the top. This is the third part for the notes. So fifth video, third parts for the notes. We're starting on cycles. What does cycles mean? Okay, those kind of things. So if you haven't seen the previous videos, please go do that. Go watch those videos, take those notes. Okay, um, these notes are also going to be available online, or for the guided notes will be available online. So you're welcome to use the guided notes if you want, but if not, paper, pencil, all the other things I labeled earlier that you can use to write on, but paper, pencil will work just fine for this. Okay. So before we begin, okay, take a couple minutes, for this 2-3 minutes. Okay, I'm not going to pause, but you can pause 2-3 minutes, however much time you need. Draw a picture of the water cycle from memory. Don't look it up. That's not part of the warm up. Okay, we're going to talk about the water cycle in just a second. So if you look it up, there's going to be no point to me talking in just a second. So take as much time as you need. Draw the water cycle, but pause the video. Draw the water cycle. Label each of the sections as best as you remember from a couple months ago. Okay, so go ahead and pause right now. All right, now you're unpaused. So hopefully you didn't draw a picture of this water cycle that this dude is writing, even though that is super cool. That's not what we're talking about. Okay, what we're going to be talking about is we're going to be talking about the actual water cycle, the one in nature. Okay, this is going to be recap, so we're going to go through this pretty quickly. Okay, looking at this photo, we have a couple different things to remember and to go over. Okay, so we're just going to go over each of the terms. Okay, so moving from evaporation, we see evaporation here, here, and here. Okay, evaporation and, oh, I forgot, right here as well. Okay, evaporation. Evaporation when water vapor forms. Okay, so from a liquid state, water vapor is created. Okay, precipitation is when it rains, snows, hails. Okay, we see precipitation right here and right here. It's snow here, it's rain here. Precipitation forms. This happens because water condenses. Okay, water condenses in the air. Water vapor condenses to create clouds. As clouds form, more water vapor comes together. The darker the cloud, the more water vapor. The darker the cloud, the more water available to rain. Okay, so we have condensation. Condensation here, condensation here. Okay, sublimation. Oh, I forgot this one up here. Transportation. Cloud moves from here to here. So if you want that written down, transportation, cloud from here to here. Whoop-de-doo. Sublimation. Okay, when solid water turns into a gaseous form of water. Solid water like snow turns to water vapor without going through the liquid stage. The opposite of that is deposition. Okay, gaseous water, water vapor, turns into snow or ice, solid form of water without going through the liquid stage. Okay, next one, runoff. Runoff we see here and here. Okay, liquid water, or in this case up here, solid turns to liquid, liquid moves across a landscape. Okay, in this case, liquid's just moving. Okay, so liquid is moving, liquid water is moving from one section to another. Okay, infiltration, down here. Water is going to enter the soil. Percolation, soil water continues into the soil. So water that's already in the soil is going to go further down. Plant uptake, you see it right here. Water is going to be absorbed through the roots of a plant into the plants. Transpiration is when plants release water vapor through their leaves. Okay, within the process of photosynthesis, they're going to release water vapor into the air. Groundwater, that means, or groundwater, I guess it should be groundwater flow, but in here it's just labeled groundwater. Water that flows underground. Easy enough. Moving into the nitrogen cycle. Okay, so for this, I'm going to give y'all a picture, and you're going to label in the different sections of that picture on the Google document, or they're just going to be labeled as names with this picture on there, and then you're just going to label the definitions and stuff like that. Okay, I'm not sure exactly how I'm going to make that just yet. Okay, so nitrogen cycle. We're going to be talking about within each of these things sinks. Okay, not like a kitchen sink or a bathroom sink. Okay, sink is where things collect. Okay, and it has an overarching name. So an example of a sink on our diagram is going to be our atmospheric nitrogen, our N2, up here. That's going to be one of the sinks for nitrogen within a nitrogen cycle. Okay, so a sink for nitrogen is atmospheric nitrogen. We're also going to have ammonium. That's how it's pronounced, ammonium. It's NH4. It's down here, NH4, ammonium. Okay, nitrates, NO3. Oh, I have that backwards, don't I? Oh, I do have that backwards. Nitrates are going to be NO2. I just read it. a little different. Nitrates are going to be NO2. My apologies. So that means our nitrates are going to be NO3. Okay, and I should have remembered that from that trick. Okay, nitrite. The difference is the nitrate ate another oxygen. Okay, should have a bigger number. This should be NO3. This should be NO2. My apologies. The next one we got is organic matter. Okay, OM. That's how it's going to be labeled. Ooh, from here on out. OM, organic matter. Other one was going to be fossil fuels. Okay. So within our nitrogen cycle, we're also going to talk about movement. How do things move from sink to sink? Okay, because we're going to have different collections of things across our areas. Okay. So one way that it does is it goes from lightning or nitrogen fixation. So lightning is going to happen. It's going to send atmospheric nitrogen into the soil. That nitrogen is going to get picked up by nitrogen-fixing NF bacteria, and it's going to fixate into the soil as ammonium. So this bacteria is going to transform it from N2 to NH4. It's going to put on some hydrogens to make it NH4. Precipitation, okay? So it's going to change atmospheric atmospheric nitrogen, and it's going to put that onto the organic matter. Okay, it's going to go into the plants, it's going to go onto the soil, it's going to go into the organic matter. Okay, so N2 to OM. Mineralization. This is when, from that organic matter, decomposers are going to break it down, whatever that organic matter was. Remember, that's anything, trees, animals, humans, anything that's living, it's going to create organic matter. Decomposers are going to break it down and make them into NH4. So it's going to take that N2 that was in organic matter and break that down into NH4. Nitrification. Okay, that is when we have NH4 and it's going to go into NO3 and it's going to go from, remember this is backwards. Okay, so it's going to go NH4 to NO2. And then nitrification is also when it goes from NO2 to NO3. Okay, I know that's a little confusing. I really apologize for that. Okay, should have looked a little closer on that guy. So NH4 to NO2 to NO3. Nitrogen cycle movements. Okay, nitrogen uptake. This is going to be right here. Any plant is going to take up nitrogen from an NO3 stage. I'm going to cover it right there so it says 3, NO3 stage. Okay, NO3 to plants. Denitrification happens when we have NO2 fertilizer that's going to go on to, NO3. NO3 is going to go through denitrified bacteria and it's going to go to the atmosphere. You can be NO2 or N2 or N2O. Okay, a little different. Okay, going to go through the denitrification bacteria, different than the nitrification bacteria. So, another section we're going to talk about within each of these cycles. I know I'm pushing time here. Human impact. Okay, fossil fuels are going to be the biggest impact here. Now, I guess not the biggest, but it's one of the bigger impacts. Okay, we've talked about this before. So, in this, they're going to compress and change into fossil fuels over a long time. Their nitrogen is going to find its way into these fossil fuels. That could be coal, oil, natural gas. When we burn it, it's going to release those fossil fuels into the air. It's going to create NOx, the NOxes, which are going to have devastating effects for the atmosphere. We've talked about those before. Okay, the NOxes and SOxes, they're going to lead to smog and smoke. I'm trying to remember. An acid rain. I remember acid rain was the SOX, but I think NOx is going to be in there as well. Okay. Biggest impact, I believe, in the nitrogen cycle is going to be from fertilizers. Okay. Most of the time, what you see for our fertilizers is going to be NH4. So we're going to be putting ammonium into our soils to promote plant growth. Okay. What that could potentially lead to is leaching, which is when soil water moves to a surface body of water. Okay, so from here, our soil water is going to leach into this body of water, and it's going to contain all of these nitrogen nitrates here. That could be a very dangerous part. Or it's going to run off that field. So all that fertilizer that the farmer just put on, it's going to run off into this little area, okay, this little body of water. That leads to eutrophication. Okay, now, eutrophication, it's a big, big deal. Okay, this is the whole reason why we talk about the nitrogen cycle to begin with. Okay, eutrophication is when an excess nutrient load is within a body of water. Okay, so excess nutrients are put into the water. This can lead to exponential growth of algal blooms, these guys. Okay, some species or some ecosystems need this. Okay, they look like this for a reason. But when there's excess nutrients, what that does is it promotes more algal growth. Okay, these nutrients cause an increase in phytoplankton. The algae is growing. When the algae grows, it's going to expand and go all over. And it's going to take up a lot of room. Once those nutrients are gone, it's going to start dying off. Those algal blooms are going to start dying, which leads to them falling to the bottom of the pond, lake, river, wherever it is, lead to the bottom of that, and then they're going to start to get decayed by all the other things that normally decompose those. Those decomposers need oxygen. So what it's going to lead to is it's going to lead to an oxygen level depletion, because we're going to have an excess amount of living things that need to be decomposed. Those decomposers need to use a lot more oxygen than normal, which means that they're going to be creating a dead zone. There's going to be no oxygen left within that area, so nothing else gets to live. No fish, no crustaceans, nothing gets to live there. Okay, we're losing oxygen. We're losing habitat, losing food. Okay, so we're going to stop it at that nitrogen cycle. I know we're a little bit over. Hopefully we'll make up that time at the very end. Like I said, this is the 5th video, I believe. So the next video will be the 6th one. So I'll see you in the next one. Thank you.